Why does grasping the concept of periodic functions matter in various fields? Here's a fascinating reason: the Fourier series. In simple terms, a Fourier series is a way of breaking down periodic functions, those that repeat over time, into simpler parts. It's like taking apart a complex piece of music and identifying the individual notes that make up the melody. This concept was introduced by Joseph Fourier in the early 1800s, and it's become a cornerstone in fields like mathematics, engineering, and physics. And imagine a periodic function as a wave. The Fourier series represents this wave as a sum of simpler sine and cosine waves. Each of these waves has a specific frequency, amplitude, and phase, and together, they combine to recreate the original function. Picture a symphony orchestra, where each musician plays a different instrument. Each instrument produces a different sound wave, and when played together, they create a rich, complex piece of music. That's similar to how a Fourier series works. It combines simple sine and cosine waves to recreate a complex wave. But how do we find these simpler waves? That's where the concept of orthogonality comes in. In mathematics, two functions are orthogonal if their integral over a certain interval equals 0. Sine and cosine functions are orthogonal over any interval of length 2p, which allows us to extract the simpler waves from the complex one. Why does this matter? Well, the Fourier series has many practical applications. In signal analysis, it helps break down complex signals into simpler ones, making it possible to analyze audio and electrical signals. In image processing, it helps analyze the frequency content of images, which is useful for image compression and edge detection. It's also used in modeling wave propagation and even in cryptography for encrypting and decrypting data. Take the example of different types of signals. A square wave, for instance, can be represented by a Fourier series with odd harmonics only. A sawtooth wave, on the other hand, can be represented by a Fourier series containing all harmonics. And a sine wave can be represented by a Fourier series with only the first harmonic. So, there you have it. The Fourier series is a powerful tool that takes apart complex periodic functions and breaks them down into simpler sine and cosine waves. It's the mathematical equivalent of decoding a piece of music, and it's used in a wide range of fields, from signal analysis to image processing and even cryptography. So the next time you listen to a symphony, remember that mathematics is playing its part in the background, breaking down the complex into the simple.